Computer Science and Automation at IISc. Previously, he has also been a research staff member at IBM Research India Labs. His research interests are broadly in the areas of programming languages, program analysis, and software engineering. Today, we welcome him for his talk on analysis of software requirements.
Thank you. So thanks for coming to the summer school. I hope you have been taking good use of it so far. It must have been a tough time, like, sitting through so many talks. But even if 20% of the material goes into you, you'll probably benefit somehow. So hoping for the best that you are enjoying it. Some of you may have noticed the title of my talk has changed. There's some chopping off here. Okay. So the title of my talk has changed. The content also has changed entirely. It's the reason is that the talk I was going to give turned out to be very similar to the talk that Karthik Nagar, a student yesterday, would have given about data flow analysis. So I switched my topic, and this is where we are today. So, so this talk is about software design. Designing and creating software. So as you all know, software design is a major aspect of the IT and the tech industry, right? Everything runs on software these days, including the new Android watches. This is not one of them, but even the watch runs on, it has a dual core processor and it runs software. So now there's this Android glasses also, and so on. Right? Everything's going to be driven by software. From that starting all the way to cloud and mainframe and rocket launching software and everything. So there's software in all kinds of places that you. And modern cars, each of them has some 30 or 40 microprocessors doing different activities, which is like 20 years ago, not even one microprocessor was there on the car. So software design is becoming very important in every domain. Everybody has to design software, including in areas where people were not designing software in the past. So, how many of you have taken a course in software engineering? Like any kind of course, like okay, almost all of you. So you might recognize these 5 phases of software engineering, right? It's called the waterfall model for those who are. So gathering requirements, design. This may be a slight variant of what you have seen. So this is interface design, then development, and then testing. So what is requirements analysis? So anyone? Yeah? Yeah, how about? I meant you actually. From the target audience, right? From the users, excellent answer. Right? Understanding the user's requirements so that you develop appropriate software for the user. Okay, this is a very important step in software development. Not enough attention is given to this in the formal modeling process. There are a lot of tools out there which will help you, do coding, like IDEs and compilers and debuggers and testers and all that. There's a lot of tool in this space, tooling. Very little here. So how do people do requirements collection and analysis at this point in the industry? Communication how? How are requirements captured? Interviews, but in what form are they represented? It's English text, in one way or the other, right? It's a Word document or a printout or a handwritten scribble, right? And is English text amenable to any tooling or analysis? Like, very little, actually. Some amount of informal meaning can be obtained from English text by say human computer analysis and all that. But there is no formal meaning to English text. If there's an English sentence which says, when I press this button, this widget must come up and I should be able to choose the city, right? That is not amenable to a computer modeling or analysis. And there's no way to actually check later automatically whether the software actually provides that feature or not, unless by human interpretation. And if people are careless in even writing that English sentence, it could mean multiple things, right? So it becomes very subjective and very particularly focused on how exactly you write that sentence, right? So then you need lawyers to understand what is being said here, right? So that's requirements. And then behavioral design is when you design the basic structure and behavior of the software. For this, some formal tools are available. So have you heard of finite state automata? Must have, many of you must have, right? So those are used, that's one primary mechanism to design a software, because it captures the various states that the software can be in and the various events and this. How many of you have heard of finite state automatons? Okay, many of you. Right? Those are used to capture the behavior of software in some way. And there's a lot of analysis you can do on finite state automatons. And then, so let's not focus on these things today. So the focus of my presentation today is on this and this. Primarily on this, but also a little bit on this. Right? So I'm going to show you a tool, a real tool that you can use instead of English documents and Word documents to capture your requirements. So it may not be a complete tool. You may not be able to capture every requirement using this tool. Partially you may be able to capture. You may still need English documents on the side. But to the extent you can capture using this tool, you can do a lot of analysis of the requirements. Right? You can see, are the requirements meaningful? Are they complete? Are they useful? Right? And you can answer all these things in a automated and rigorous way, and not just by interpreting English sentences. So hopefully we'll see what that means. Right. So one key thing why analysis of requirements is important is that if you misunderstood the requirements, then the software will turn out wrong. After 6 months, after 1 year, the customer will complain when the software is ready, saying, this is not what I said. And you go back and look at the document if you still have it. And you will see, it says, it should put out a dialog box where this button is clicked. It doesn't say it must. So I thought it's optional to click this. You know, there's arguments will come about what does should mean and what does must mean and what does can mean, what does could mean. Right? And then they will argue and they will, it will not be productive experience for anyone. Right? And then it will take another 6 months to modify the software to bring it to what the customer really had in mind. So if you can analyze the requirements as soon as the requirements are written and identify problems with the requirements, if any, along with sitting with the customer, with the target audience, then you can have a well-defined requirements before you even start writing the first line of code. So Alloy is this tool from MIT. So MIT is the very good university in the US, right? So they have developed this tool called Alloy, which lets you capture requirements in a formal way and also analyze the requirements, right? So let's see what that is. So I'm going to start with an example. So let's say the government is interested in developing a software to keep track of events such as marriages, births and deaths, right? So when a birth happens, what do you have to do with the government? Birth certificate. You have to apply for a birth certificate, right? There's a certificate for every important event in life, right? Another important event is marriage, right? Marriage certificate. If you get divorced, there is also divorce proceedings. Then when you die, somebody has to apply for a death certificate for you, right? Even when you are no longer there, right? So whether we like it or not, there is a lot of legal proceedings connected around the various stages of a person, life stages of a person. So currently, at least in India, I think there is no software behind this, or maybe right now they are developing, but traditionally no. Like when you ask for a birth certificate, they will issue a birth certificate and make a note in some file saying birth certificate number so and so was issued, right? When you ask for a death certificate, they will again issue your death certificate. They will not check whether this person was actually born even, right? I mean, there's no way to actually check that today, like, because of manual files, right? And why should you check? Why should one ideally check at all? I mean, why not just issue death certificates as and when people ask for them? Can you see any problem with that? Like, yeah, so a lot of complications can come, right? Like if you claim somebody is dead, you can use that to make certain other legal changes, right? Right, insurance, you could claim LIC endowments for a person who was never even born, maybe. So there are so many things, right? You can take a policy against somebody who was never born, then produce a death certificate, take the endowment also, right? All this can happen. It does happen even today. So I was reading in the paper a few weeks ago that in UP somewhere there is something called a Murda party. Like, you know, Murda, like, you know, in Hindi, Murda is dead person, right? Like so there are a lot of people who have land disputes go and take death certificates in the names of the people with whom they have the dispute, and then they use that to snatch the land, like that person's land was still alive, like. And so this Murda party is there to make these dead people, so-called dead people who are actually alive, they will give them tickets to stand in the elections, and then they will show that look, this person is even standing in an election, he's actually alive. I mean, I really read this in the newspaper. So all kinds of weird things happen. So the point is, if there was software, if there was a database in the government side, and if there was software that is used to register all these events, there is far less chance of all these malpractices. So what kind of database would we want? I mean, so let's keep it simple. So let's say we want to register births, deaths and marriages for now. So the database will contain information about people and about relationships, right? So when you apply for a divorce, say, there should be a proof that these two were actually married, the ones who are seeking a divorce, right? And so on, right? So how many of you have seen this kind of so-called entity relationship diagram? Okay, many of you have seen it, that's good. So each box represents an entity, right? So an entity is a kind of object, right? Here person is an entity, meaning this represents the set of all persons, right? It's like a type. If you are familiar with Java or C++, you can think of this as a type, but in a ER diagram world you can think of it as an entity, right? And similarly, man and woman are entities. So there is a set of men, there is a set of women, there is a set of persons. So in this is a UML class diagram for those. It looks like a UML class diagram also. So what does this typically mean? Yeah, generalization, inheritance. So this is saying that a man is a kind of person, woman is a kind of person. And these green arrows are called associations or relationships. What would this typically mean? So parents is the name of the relationship, and what does it mean? What does this arc mean? Yeah, so stars typically means 0 or more, right? So it means each person can have 0 or more parents, and the parents are also persons. Right? Otherwise, in general, you can have the arrow going to some other entity. Like if there is an entity houses, you could have an arc from person to houses, saying owns, right? So you know that kind of stuff, right? So in this case, the arc comes back to the same thing. And similarly, this is spouse, right? So we say 0 or 1, right? So let's say this is a requirement, 0 or 1. So please don't argue with me about some of these constraints. Some of them are relaxable depending on the situation and the domain, but let's just take some of these things to be given as we go forward. So the government wants to maintain a database of all persons with information about whether each person is a man or a woman, and also wants to maintain a database about these relationships. Who is the parent of who? Who is the spouse of who? Okay, so these things need to be entered into database tables along with some integrity constraints. So you are familiar with integrity constraints, I guess, right? So these are some constraints, let's say, that the government wants to impose. Okay, again, you can argue about whether these constraints should exist or not, whether the parents of a child have to be married or not, but let's, for the sake of this discussion, take it that there is a rule that a birth can be registered only if the parents are married. Okay? So I don't know if such a rule really exists or not. Let's say there is a rule that no one can marry their own brother or sister, right? And that every person has two parents, a man and a woman. So these are rules that the government wants to enforce. So whenever you apply for a birth or a death or a marriage or a divorce certificate, these rules have to be ensured by the software. So, but these rules are as of now written in English. These are English sentences, and this is, as usual, amenable to misunderstanding and informal discussion and not formal discussions. So let's try to make this picture more formal. Let's try to put this into the tool, both this diagram and these constraints, and let's see how to do that. And then we'll see why the tool should be used at all. Right? So the idea is to convert all of this into a tool input, and then to use the tool going forward. So this is what the Alloy. So Alloy is like a small programming language where you can capture these things. So this is the first line of code in the Alloy tool. So sig means signature. That's nothing but an entity or a class, if you think of it. And the name of the entity is person. And there are two relationships that person is involved in. Spouse is one relation, parents is the other relation. So lone means 0 or 1. So this is saying that person is an entity and spouse is a relationship from person to 0 or 1 person. So if you recall, that's what this is capturing, right? So that's just the tool representation of this picture. And what is this saying? Parents is a relationship from person to person, and set means 0 or more. So lone means 0 or 1 in this tool, and set means 0 or more. So remember, we wanted 2. We wanted the constraint that a person should have 2 persons as their parents. We'll enforce that later. For now, we are just saying 0 or more. So is this, anyone has a question on this? Because it's a very, if there are questions in the beginning, we should get them clarified before we move. So this is nothing but an encoding of this part of the picture. It's a textual programmatic encoding of this part of the picture. So is there any question here? So please do stop me if I don't have to finish everything I have, so you can take time also. Now this line is saying, sig again means entity. So this is saying man and woman are 2 entities and they extend person, right? Inheritance. Right? This extend keywords is there in Java, right? So this is similar. And these empty brackets mean that there are no more relationships that man and woman are. These are the only 2 relationships that we care about. If there are other relationships that are specific to man or woman, they could go in here. By the way, this abstract. So is anyone comfortable enough with Java to know what abstract means? An abstract class. Okay, good, very good, excellent. So what is the use of such a class? Okay, so you can define some methods, but anybody who inherits will inherit those methods, and you can instantiate those, right? So they have used similar keyword here. They have said man and woman extends person, but person is abstract. So in this world, what would that mean? What is abstract person? What would that mean? So in Java, it means you can't instantiate the abstract class. So what would that correspond to here? See, here I don't have the abstract. I just say man, woman. I don't say abstract. Okay. So this Java analogy is only for illustrative purpose. Okay, this is actually not Java code. These are not classes and methods actually. Okay, the keywords look like Java keywords, but this is actually entity relationship modeling. So it's not that man implements some method or anything. I mean, it's not like that really. So, but sure. So that's the correct answer. You can't have a person who's not a man or a woman. That's what this means. That is, abstractly persons don't have any existence. Every person, you can only instantiate men and women. But we still have this person class because these relationships are common to both men and women. Right? Otherwise, I would have to declare them separately for men and women. So this is just a way for me to declare them up and say every subtype of this participates in this relation. So it's just a way of factoring that thing. So now this picture is showing an actual database content, a snapshot. So you know what a snapshot of a database is, right? What does snapshot mean? The contents of tables at a particular time, right? These tables keep changing actually, but if we freeze the time now, and if I look at the rows, that's a snapshot, right? So this picture shows one snapshot of these tables. So in this snapshot, how many people are there? How many persons are there? So there are 3 persons. So good guess. These 3 boxes are those 3 persons, and the values inside are the names of those 3 persons. So these are sample names. Okay, this could have been Asha. I mean, this could be Priya. This could be whatever, right? But here these are just sample names. Man 1, man 0, and woman. So there's only one woman instance. So there is no kind of 0, 1 or 2 here. But this is actually different from the entity woman. Entity is a set of all women. This is one specific woman. So I always use these yellow boxes to represent instances of entities. So here's a snapshot. And what are the relationships in this snapshot? So every person will have 2 parents. Is that right? In this snapshot, is it true that every person has 2 parents? No. Man 1 has 2 parents. Man 0, any parents? No. And woman also has no parents. Right? This is a bidirectional arrow which says that man 0 spouse is woman and woman spouse is man 0. Okay? So does this snapshot respect the constraints that we want? Completely, partially? Only partially, right? Some people don't have parents, so it's not a valid snapshot. Here is another way to describe this same snapshot, more as table contents, right? So what does the man table contain? There are 2 elements, man 0 and man 1. This is the woman table only. So sorry, I have said woman here, but woman 0 here, it's the same thing. So take this as woman 0. And there are 2 other tables, parents and spouse, right? Is this consistent with this? Is this picture agreeing with this table contents? Yeah? Man 1, man 0, man 1, woman 0, right? Right? And spouse also, this is agreeing with this picture, right? So we can use either this form of notation or this form of notation to represent these snapshots. So it's becoming a little bit more complicated at this point. So this dot is the so-called relational join operator, which you might have come across, right? But I'll define it for you anyway. So man is this table, spouse is this table. So what would man dot spouse be? What is the join of this table with this table? It's a natural join. Joining using this, there's only one column in this table. So you use this column and this column as the joining column. So man 0 matches man 0. And what is the entry here? Woman 0. Man 1 matches, no, man 1 has no match here. Right? So the join is, so you have to remove the joining column from the joined result, at least in this operator. So the result is only woman 0, right? The singleton set, and that's what I've shown here. But intuitively, what does this mean? So capital man, remember, is a set of all men. So I use capital letters to indicate the actual entities, the sets, and I use small letters to indicate the individual elements, the individual instances. So man is a set of all men. So what does man dot spouse represent intuitively? Yeah, so yes, correct. Can you say it in more friendly English? I mean, set of all married women, excellent. Right? Yeah, but what you said is also correct. Right. And this is correspondingly women dot spouse. Right, so woman 0 has this match here and man 0 is coming there. I can also do dot on individual elements. It doesn't have to be the full set. So this is man 0 dot parent. Is empty set, right? Because man 0 is not appearing here. A man 1 dot parent is man 0 and woman 0. So relational join is the correct meaning of this, but the easier way to read this is spouses of men. Right? It's easy for you to read it that way. Parents of man 0, spouses of women, parents of man 1. So if you read it that way, it's much easier to understand the meaning of this dot. So any question? So remember, this dot means that the people who are in this relationship with these people. That's what the dot means. So far we saw this piece of syntax, this entity declarations and relationship declarations. We saw this dot thing. Now this is where it's becoming interesting. This is called facts. And these are those rules that we're going to enforce, that we're feeding into the tool. So these rules are called facts. Right? So there are, each line is actually a separate rule. They're just written inside this fact block. But each line is actually this and this. So there are 3 separate rules actually. There's no semicolon separator unlike in Java or C, but you can think of it as there being a semicolon here and one here and say one here. These are rules. So spouse is the name of the spouse relation. And this is transpose tilde. So what is the transpose of a binary relation? So in this case, what would be the transpose of this relationship? So you know matrix transpose, this is similar to that, right? So what would be the elements of the spouse transpose? Same? No. So you have to take each tuple and switch the order of the elements. So spouse transpose would be woman 0, man 0, man 0, woman 0. In this case, the transpose of the spouse happens to be same, the same set, right? Need not always be the case. Need not always. For example, if spouse has only man 0, woman 0, the transpose would be woman 0, man 0, which is not the same, right? But this rule is saying that this better hold. This is a rule. We want the spouse relation to satisfy this. So what is the intuitive meaning of this? What does it mean to say spouse should be transitive? So it's easy, right? It's like you can't have an asymmetric marriage relationship. It's very natural, right? So, but the interesting thing is you can mathematically represent this intuitive human concept in a very nice, precise mathematical way. So maths is used to capture requirements That is the interesting takeaway here. Requirements are being captured purely mathematically using set theory. So, so what does man dot spouse means? So remember, we have to read it as people involved in this relationship with this. So this is a set of spouses of all men. So these are married women. Intuitively. So in means subset. Not element of. It seems like element of, but it means subset. So this is saying this should be a subset of women, which is a set of all women. Right? So let's ignore this part for a moment. So what does this mean? It seems very intuitive. Why should I even write this? But what does this mean? What is the implication of this? Well, actually it's a subset of women. That's all this is saying. But what is this constraint? What is it imposing? It's yeah, so what can you, yeah, so this is basically banning gay marriage, right? Like, which is a debated topic all around the world. Say many countries allow it, India still doesn't allow it. Right? But this rule is saying that there is, I mean, when would this be violated? If man 0, man 1 was an element of spouse, what would happen? What would show up here? What would be the result of this? If this was man 1, let's say, so what would men dot spouse be? It would be man 1. It would be the singleton set man 1, which is not a subset of women. So this constraint is failing. Right? So this constraint is ruling out snapshots where men are married to men. It is enforcing a rule that the government wants to enforce. Or in this case, the government is nothing but the user of the software. In general, any user of a software. So forget this example. Just take a step back. It could be an inventory example. It could be a post office software. It could be a banking software. It could be a e-commerce, Flipkart and all this software. Whatever the software, the users have some requirements. Right? Railway booking. In railway booking, what are some key constraints? There are many actually, but what is the most important constraint in a railway booking software? Availability. You can't give out seats that don't exist. Right? You can't give a single seat to two. You can't reserve it twice over. Right? And there may be various other constraints also. Right? If the person says, I will only take a lower berth, you can't assign them to a middle berth. Right? So these are constraints. And allow lets you write down the constraints mathematically. And this is the other symmetric component of that. So maybe we don't have to go, so this is a little bit more complicated. I'll just read this out for you. This is saying, this is like a quantifier. This is saying for all P in person. So lone means 0 or 1. So for every person, this is saying for every person P. So what is P dot parents? Read it in English, parents of P. Parents of P and this intersection. So this is the set of parents of P. If you intersect with man, what is that intuitively? Father. Father. Lone means 0 or 1. You should have 0 or 1 fathers. Actually, I should have said 1 here instead of lone. But that still doesn't say that. No, but lone allows 0 or 1. You could have 0 fathers and 1 mother, or even 0 fathers and 0 mothers also. So I should have said 1. Let's see. Well, we'll come to that. And this and is saying the same thing about this, right? So are you getting the idea behind these? How this math is being used to encode the rules? So now is time to quickly look at the tool. So I have less time than I thought I would, so I'm going to have to show only the demo partially. So this is the alloy tool. By the way, this So this is the alloy tool. This you can see this jar file, bin alloy jar. I'll tell you where to download this jar file from later. It's available on the internet. All you have to do is to download this jar and just say Java minus jar. That's all. The tool starts up. It's a very simple installation. There's nothing to install all that. Just download the jar and say Java minus jar and the jar file. The tool starts up. And this jar is available on the internet. So this is the, on the left side you type in the alloy code. So is this font big enough for the people in the back? Okay. Otherwise, if there's a lot of empty space here, you can come to the front. So this is the actual alloy code. We have seen most of it already, right? Sig, person, spouse, parents, man, woman, extends person, right? Fact is a constraint. So this is actually slightly different from what I said, and this is actually the right formulation. So this is saying for all persons P, this is saying there must exist one woman which we are calling mother for now. And mother is nothing but a variable name actually. It's not a special, only woman is an entity. And there must exist one instance called father in man, such that P dot parents, the parents of P is plus is set union. Mother and this father. So this is saying there must be exactly one woman and one man such that this constraint holds. Okay, you may not fully grasp this, but I hope you get the intuitive idea behind this. So I'll need a lot more time to go through this bit by bit, but you get the idea, I hope. So this is saying that every person must have one mother and one father. And these are these other things we saw this. There are three other rules I have added here, okay, which we did not actually see so far. So what is this saying? So what is this rule saying? Well, the comment says this here, but so there must be no person P. This is such that. Okay, so let's read this bit by bit. What is this? P dot spouse dot parents. Notice there are two dots. Parents of, spouses of P. Spouses of is just spouse of because there is only one spouse. So parents of spouse of P. What would that be? That would be your in-laws, right? Like that would be P's in-laws. And this is P's parents itself, this set. And what is this and? Set intersection. So take intersection of in-laws set and parent set. And what should that give you? Null. So, so this is saying sum means 0, sum means 1 or more. So this is saying there should be no person P such that in this intersection set there is 1 or more elements. Okay, it's a little complicated. What is the intuitive meaning of this? You cannot marry your sibling. That's what it means if you think about it. There should be no person such that their in-laws and their parents are overlapping. And the only way that can happen is if you marry your sibling. Right? It's a little complicated mathematical encoding of this. Right? The only way your parents and in-laws will overlap is if you are married your own sibling. And this is saying there should be no such person. Right? Again, it's a nice mathematical encoding of a set theoretical encoding of a property. Then there are some two other rules which This is saying can't marry a sibling, can't marry your own parent, your parents have to be married and so on. Okay, these are the encodings of these rules. So now we are put it into the tool, but what is the tool going to do for us? What's the use of putting all this in the tool unless there is some value, right? I will now show you the value of the tool. Look at these. These are the constraints that we have put in. The question now we are asking is, are these rules enough? Do we need more rules, or are these rules too much? Should we remove some rules? Right? The customer, in this case the government, wants to know whether these rules are suitable. They seem suitable. Right? If you just write it in English document, you will say, yeah, these rules are fine. I mean, this is what I want. Right? But the rules could be too strict or too liberal. An English document will never tell you that. Yeah. 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 This one? Yeah, there. Yeah.
They need to be
A man and a woman. That, yeah. Yeah.
that is just taking that this spouses of all the parents.
This rule?
Yeah. The spouses of all the parents are in the set of parents. So it doesn't really check that.
So this is saying that parents of P, this is saying spouses of parents of P, they have to be equal to each other. They have to be equal to each other. So this is ensuring correctly the intuitive notion. Two parents you have, you take the spouses of those, you should get back the same two people. So if P has two parents, mother and father, and I want to check that M and F are married, right? What would be so if I take the spouse relationship, if I take the spouses of parents of P, I should get back the same M and F. The spouse of M is F and the spouse of F is M. And if I get back the same set, it means that the parents of P are married. So I think there's no problem there. But good question anyway. So the tool is going to answer the question, are these rules enough or not enough? Seems like magic, right? How would the tool know whether these rules are enough or not enough? Even I don't know as a person actually. So let's see how this goes. Clearly, if you only write these rules in English in a requirements document, no analysis can be done. Except people can argue over this is enough or not. But let's see what the tool does. So there is this, so the show is like I don't want to go into the details of this, but what the tool is going to do is it's going to show instances or snapshots which respect all these rules. So the tool actually does not know whether these requirements are too strict or not, but it will show you snapshots which respect these rules. And what would you do when you see those snapshots? You can look at it as visually, and you can see whether the snapshot looks good or bad. There is actually no magic. It does not know whether the rules are enough or not. Only you know that. But the tool, the power of the tool, it lets you see snapshots which respect these rules. So let's see the snapshots. Right, I'll do this. It says instance found. So this is a snapshot. Actually, that's not interesting. This is an empty snapshot. There are no instances. It means that there are no people in the world. Empty. Empty set happens to satisfy all those. When there are no people, all those rules are satisfied. Okay, so it's but not very interesting. So this next button lets you. This is very interesting. It says, "Show me another snapshot." So now you know what these boxes mean, right? These are instances, and the red arrows are the parents' arrows. And the green ones are the spouse arrows. And if you just hover over the parents, the spouse arrows are made dim, so you don't have to. Right? Now this is a snapshot. Is this looking okay? See, you are a user of the software, you have to say whether this is okay or not. Should the system allow this snapshot or not? No, not okay, right? What is the... Yeah, there is a bidirectional arrow, that's one problem, right? It's very weird. For woman 2 to be parent of man 0 and vice versa. Right? And there are other similar, there is also a cycle here. Right? There is a cycle involving man 1, man 0 and man 2. Right? So you thought the rules are enough. The integrity constraints that you wanted to impose on the tables, in English they look like they were enough. It turns out they are not enough. They allow such garbage results. So there is no magic in the tool, but by showing you instances of which satisfy your requirements, it lets you see whether your requirements are good enough or not. If you see a bad instance, you know that your requirements are faulty. Right? So you do not capture requirements properly. It's allowing such garbage. And if you don't do the analysis using this way, you may develop a full software based on those requirements, and the software will end up allowing all these cycles and all that. So what's the use? It's all the integrity constraints are being violated, and it's just a broken system. Right? So this is is spouse looking okay at least? So far it's looking okay to me. So, but anyway, let's fix problems one by one. I don't like these cycles and bidirectional arrows. Due to lack of time, I'm not going to make you think about how to fix this problem. It's I'm just going to cheat. I know what the solution is. I'll copy paste it. I'm going to add one more constraint. Into this. I'll just tell me what is this constraint saying, this new constraint. For that you need to know what this new symbol caret here. So P dot parents means parents of P. P dot caret parents means ancestors. It's the transitive closure of the parents relation. P dot caret parents is any instance which is related to P by one or more applications of the parents relation, the set of all ancestors. So what is this rule saying? There is no person P such that. So in means subset of our. Yeah. P is their own ancestor, right? That's the cycle we saw on this bidirectional arrow, right? So this was the rule that was missing. The requirements were incomplete. Right? This rule should have been there from the beginning. It's just human oversight that the rule got missed out. So I'll put a comment here just so we track this. So now what should we do? We found an error. What do you think we should do now? Close this thing. Are we done? Should we go home or like? I know it's getting time for the talk again, but are we done? Like, this should take care of that also. If there is a bidirectional arrow, P, you go to the arrow one way and then you come back. P will be their own ancestor. So this should take care of both the bidirectional and the cycle. Right? Anyway, so let's ask the tool, are we done? Let's say, show me instances of this updated requirements. Okay, it's saying instance found. This is the empty instance. Fine, empty is, let me say show me more instances. What is this saying? So forget this note. They are saying no more instances. What does that mean? What does no more instances mean? Right, so yeah. So every person should have two parents, and where does this there is no finite set of people will satisfy these constraints, right? And why was it not there earlier? Why was this problem not there earlier? Because you allowed these cycles and you allowed finite subsets of people to satisfy these requirements. Now this is not allowed. And you wanted to tighten the requirements and remove some bad behaviors. Now you have tightened it so much that nothing is allowed. The system will not allow any birth or death or any marriage to be registered. If it would, an instance would have been shown. Right? That's the other way of using this tool. If it's not showing instances that you want to see, it means your restrictions are too tight. Not some good instances are not coming across, right? So now we can fix this in various ways, right? Let's not go into that. There are, I was going to show a way of fixing it where we'll have two special people called Adam and Eve, right? Who need not have parents. Right? Everybody is required to have two parents. I'm going to put an exception clause here saying Adam and Eve don't need to have parents, and they can marry and they can have children, right? So I don't have time to show that, right? And that kind of breaks this deadlock, and actually after that the requirements become very well established. But due to lack of time, we will not go into that. So I have about 5-6 minutes more. So just to summarize, the tool lets you write down requirements in mathematical form, and it lets you seize the results of these requirements, these snapshots, and it lets you decide whether the requirements are too strict or too liberal and adjust the requirements appropriately. Right? And if it was just a text document, you cannot do this. It's just lying there. There is no help in understanding this text document. So once again, this is this typical cycle of using this tool, this flowchart. Right? You create a so-called model, and then you generate the next solution, the instance. So let's forget this box for a moment. So this I means, what does this I mean? You look at the instance, right? You are the best judge of whether this instance is good or not. And if this instance is not okay, something is wrong, you adjust the requirements and then you try again. If the solution is okay, you just see the next solution. And there is actually no valid point to stop this process. You can keep going. It is possible that the first 8 instances are okay, unfortunately, and the 9th instance shows some problem. In this process, there is no definite way to know that you are done. So it's so long as you can find erroneous things, you can fix them. But unfortunately, there is no completion here. In the sense, the tool cannot give you a guarantee that you have seen all because the number of instances is infinite actually. You can have 5 people, 6 people, 7, 10, 15. Some bad problems come up only when you have 20 people in the relationship. So there is, it's more like a debugging tool. You can find errors, but you really can't know that you're done. Right? It's only a hope. But it's still better than nothing. Better than no analysis. So I'm going to have to spend the last 5 minutes showing you some math behind how the tool actually works. Right? So we code up this model. The tool generates snapshots. How does it do that? How does it produce these snapshots that respect these things? Right? That's what we are going to look at. So what the tool first does is it converts the program that you give into mathematical formulas. So I am saying this piece of code becomes this formula. So you are all familiar with first order predicate logic. This is just basic first order logic, right? So what is this formula saying? Actually there is a for all p here, I forgot to put it. For all p in person implies that p in man and p not in woman, or p in woman and p not in man. Is that fine? Do you believe that this is the correct encoding of this? This is saying man and woman extend person and their disjoint sets. This is saying every person must be a man or a woman, but not both. It's not possible that a person is neither a man nor a woman as per this rule. Right? So this is nothing but the mathematical equivalent of this. This is saying that there is no person such that some means some common intersection. the parents and spouses should have, you can't marry your own parent. That's what this rule is. So this is saying for all P, if P is a person that does not exist, another Q such that Q is a spouse of P and Q is a parent of P. Right? This is just a mathematical encoding of this. So the first step is to convert the code into these mathematical formulas. The next step is to generate instances or solutions to these mathematical formulas. So I'm going to have to rush a bit. So one way to generate instances is to use a so-called theorem prover. But that's a very expensive approach. It does not work very well. So this tool actually uses a different approach. So there's actually one point which is worth making. I said run show for 7. This number 7 means that show me snapshots with at most 7 people. Right? So if you say 7, it will not go beyond the size of 7. It will stop after you have shown the snapshots of 7 people. And this number must be given. If you don't give this number, the tool will not work at all. It will not show any instances. You can say 10 if you want, you can say 2. You must give some number. You cannot say show me all instances of all sizes. This is as I said, if you use 7, you are satisfied that up to 7 everything is okay. You can't be sure about 8. Right? So this is the limitation of this tool. But this 7 is called the bound, the population bound. You are binding the population to a certain size, right? And this is important for the algorithm. So now for simplicity, let's take the bound to be just 2. I use 7 there. Just for illustration, let's say it's just 2. So we are only interested in snapshots where there are at most 2 people. So I'm going to show how to convert a formula of this kind into a propositional formula with just normal Boolean variables and with no quantifiers. A quantifier-free propositional formula, right? This is an interesting thought, actually, a concept. So the idea is, we know there are 2 persons. Let's call them person 0 and person 1. Only 2 persons are there as per the bound, right? So we'll introduce 2 Boolean variables, M0 and M. What's a Boolean variable? It's a proposition. What is it? It can take values true or false, right? So M0 can take values true or false, M1 can take values true or false. So these are 2 Boolean variables. This is the meaning of these variables. M0 is true means the 0th person. So remember there are 2 persons, 0 and 1. The 0th person is a man. This is the way we are going to use this variable. And M1 means the first person is a man. Similarly, I have W0 and W1. Right? So how many variables have I introduced so far? Boolean variables? 4 Boolean variables, right? I'm going to put in more Boolean variables. This parents, remember the parents is a binary relation. I'm going to have 4 Boolean variables. 4 because it's 2 times 2 and my bound is 2. What would P00 mean? If it is true, it means, so Pij is true means that J is a parent of I. So if this is true, 0, it means 0 is a parent of 0, 1 is a parent of 0, 0 is a parent of 1 and 1 is a parent of 1. And similarly for spouse, right? This is all. In this example, I need these 4 plus 8, 12 Boolean variables. So, but where are we heading? So this is the formula we just saw, right? What is this saying? Every person P is either a man or a woman, right? Now, does anyone want to try it? What would be the equivalent propositional formula using those variables? So these are the variables. So you don't need these even for that. You only need these 4 variables. How would you encode it? Every person is either a man or a woman. Using these 4 variables. Yeah, someone was saying something. M0. So M0 and W0 bar, is it? M0 and W0 bar. That would mean M0 and M1. No, you don't want that. Okay, I think we are getting the rough idea, right? Like, so I'll just show the correct answer, but I'm sure all of you can work this out if given a few more minutes. So in the interest of time, this is XOR. Right, so this is saying M0 or W0, one of them should be true, which means 0th person should be a man or a woman. And this is saying the same thing about the first person. Right? This is not saying that both should be men or both should be men or anything like that. Right? So this is the propositional encoding of this formula. Now that we have this encoding, so the tool goes in these steps. It first takes your code, it converts it to this formula, then it converts this to this formula. And I didn't show you the algorithm for converting this to this, but that is a mechanical algorithm. Right? It's a very simple algorithm. So now what can you do with this formula? The point is to generate instances, those snapshots. So now you can use any solver, a SAT solver, so-called SAT solver. You throw this into the SAT solver, it shows you solutions. And every solution will correspond to a snapshot. So if the solution says that M0 is true and W1 is true, so that gives you a snapshot in which person 0 is a man and person 1 is a woman. Right? So every solution to this corresponds to a snapshot, and vice versa also. Every snapshot also corresponds to a solution to this. Right? So is this intuitively clear how solving these formulas gives you snapshots? Right? This is what the tool does. It creates the formula, it finds solutions. For each solution it draws the picture and shows you snapshot. Those correspond to solutions to these formulas. So this is the other one. Your spouses and parents cannot be common. Your spouse cannot be your parent, and actually this is slightly more complicated, but you can parse this. So this is saying that it shouldn't be true that 0 is 0's spouse and 0 is 0's parent, and similarly for other cases. So I'm going to go to the last slide. I'll already overshot by a couple of minutes, I think. So what is this slide saying? So this book is available on Flipkart. I think it used to be available at least. This book is about alloy. It's also about the theory behind alloy and how you use alloy and requirements analysis in general. So this is a very nice book. It used to be available for 300 rupees or so. I hope it still is. Right? So you might want to buy this book. And this is the URL from which you can download that jar. You don't have to write this down. If you just search alloy MIT, alloy software MIT, you should get this link. Right, and I wish to thank this colleague of mine who helped me learn alloy myself. And that's it. And I think we are out of time, so I would just suggest that if there are any questions further, we can step out and talk about it while the next person sets up the.
Thank you, sir.
So I'll be here for a few more minutes if you have questions. Thank you for listening.